Hey friends, it's Scott. I want to thank our new sponsor, MailTrap, modern email delivery for developers. They integrate straight into your code with their SDKs. You get unified transactional and promotional email delivery, 24/7 support. You contact humans, not AI chatbots. We'll give you 3,500 emails monthly in the free tier, and you can try them out at mailtrap.io today. That's mailtrap.io today. Hi, I'm Scott Hanselman. This is another episode of Hansel Minutes. Today, I'm chatting with Loris Cro, the VP of Community at the Zig Software Foundation. How are you?
Hi, Scott. I'm good. Thank you. Thank you for having me.
Yeah, thanks for hanging out. So you're always live coding, you're on Twitch, you're out there talking about Zig. When did you discover Zig, and what programmer were you before Zig came into your life?
Yeah, I was a very different programmer back then. So I never really. So Zig is a low-level programming language.
Mm-hmm.
So you do systems programming stuff with it, and in university I studied bioinformatics. So I never really got much into lower-level programming, except I had one course where we had to do some string algorithms in C because DNA analysis wants you to do string algorithms fast. But that was it. That was all the experience that I had. At some point, I found myself at Redis Labs, and I needed to show people how to write Redis modules, which are a way of adding custom extensions, custom data types to Redis, which is a really cool system. But to do that, you need to use a lower level programming language because you need to produce a DLL, and you're interfacing with C APIs, with C APIs. So I was shopping for a language that would allow me to show how to do this stuff to people that would be that would look less scary than C or C++. And I stumbled upon Zig, and I kind of fell in love with it, and I started interacting with the Zig community. And then after a while, I jumped ship and joined the Zig Software Foundation.
Mm-hmm. And Zig is comparatively young, isn't it? I mean, Andrew Kelly started it just about 10 years ago. Is that correct?
Yes. Yeah, that's correct.
And I'm looking online. The latest release is 0.152. Does that mean beta, or does that just mean that we don't want to say 1.0 until it's perfect?
It means that we will break your code. Well, it means that it's not done. There are a lot of things in the language and toolchain that are still work in progress, for sure. But it also means that you should expect breakages every time you update Zig. They're not terrible usually, but it's not V1, so there is no promise of backwards compatibility. And in a sense, it's our superpower because it means that every time we realize that something needs to be tweaked, we don't have to fight with legacy promises. We can just break.
Mm-hmm. So let's talk about C and C++, because Andrew was frustrated with C and C++, specifically around the tooling, cross-compilation, and the build systems. What is the problem in your mind with C++ that would cause someone to be so frustrated that they would make their own programming language and toolchain in response?
That point. Okay, well, I cannot speak for Andrew 100%.
No, just speak for yourself, because you did jump ship.
Yeah, I did jump ship. So I think that I'll give you one example that has to do with C and C++ that I diagnosed less than 24 hours ago. Somebody wants to use OpenCV, and OpenCV is a C++ project. And for people who don't know what OpenCV is, it's a very cool library that allows you to do computer vision. So you can recognize objects, track them, do all kinds of very cool stuff. So this person wanted to use it, but it turns out that OpenCV has no C bindings. So it's a C++ project, and they want you to use it from C++. The problem is that languages that aren't C++, they don't want to talk to C++ most of the time. They want to talk to C. because there's a thing called the ABI, which is about interoperability between, let's say, languages and executables.
The application binary interface.
Yes. And so there are third-party projects that maintain C bindings for OpenCV.
Mm-hmm.
And apparently that's what you're supposed to use. One of those is called GoCV. So these are bindings, C bindings for OpenCV that then get consumed by a Go package, and that ultimately exposes OpenCV to Go. So this person then was trying to take those headers and use them to talk to OpenCV from Zig. But they were having a compile error, and they couldn't figure it out because they were not C++ programmers. To be clear, I am not a C++ programmer either. There's probably an infinite amount of things about C++ that I do not know. But one funny thing about what happened here, which we ended up solving this fairly quickly, is that the bindings had a mistake in them where they were including another library in the wrong place. They were including a C++ header inside of a extern C block in which you don't want to have C++ stuff.
Mm-hmm.
And so that is wrong. But wait, how did the Go people not notice? Why does it not break for them in the compilation? Well, it turns out that in C, whenever you import something, there's usually the if not def guard at the top of the header file that prevents you from including the same header file more than once, because that is
a very common thing to do.
Yeah. So what was happening basically is that the Go project was importing that header file from somewhere else earlier in the build process. Mm-hmm. So that second time where that header was mentioned inside the external block, the if not def guard would trigger and would prevent the template from expanding a second time. So the header file from expanding a second time. So long story short, it was a problem derived from order in which these header files were included.
Mm-hmm. Oh, wow.
That is one.
It was almost like it worked because of luck, because this one got there first.
But this is not the first time that I see this, because I've seen quite a few C and C++ projects that have this issue in them. Because what happens is that I understand. I think it's understandable because people, you have a bunch of files. You. It's a big project. Maybe you don't have control over everything. So once it works for you, you don't start questioning whether there might be, you start questioning why does it work. You're just happy that it works, and then you move on to something else. So my point, I guess, the reason why I told this story is that in my experience, C and C++ are full of these problems. They're the way they work is it's full of rough corners and you keep getting caught. So if you're a new programmer, like for example, thinking about my personal experience, I never got into lower level programming before discovering Zig, not because I hated the idea. I would have liked to learn more about lower level programming, but my impression of the amount of effort necessary to navigate the complexity and the weird quirks of 40 years basically of accumulated stuff in the C and C++ world. I say 40 years because I'm talking about myself like a few years ago. By now, I think it's more than 40. So there is so much stuff there that it felt to me that it would have been too much effort. And I think that Andrew felt probably also the same way. Some of that, and some also because if you mention C++ specifically, he likes C way more than he does C++. So he wanted to have a more C-like experience than C++. No objects, no distractors, less hidden behavior.
Mm-hmm. But philosophically, it's not a vote against C or C++. It's more a declaration of why is systems programming so hard? in the in the beginning part of the 21st century. We're sitting here and we're still having frustration. So it sounded like he and the folks at Zig are trying to look back on history and say, all right, let's do it better. Let's do a better compiler. Let's have fresh ideas. Let's have a new build system.
Yes.
But with Rust, though, has captured everyone's imagination. Where do you see Zig living in a world of Rust? And why are people so enamored with Rust?
Well, there is, okay, I'll tell you one thing that I think Zig does that Rust does not, and this is not like much of a matter of opinion. This is like just an objective fact.
Sure.
Because, when you're talking about language comparisons, then things get heated very, very easily. But this ties back to your point. This is not against C or C++. This is about kind of modernizing the concept of systems programming, but in a way that is different from Rust. So here's one important example. I did mention a moment ago that we were wrangling a C++ library. I do that a lot nowadays because it's common for people to try and replace make files and C make files with the Zig build system, not just to reinvent the wheel, but because Zig is able to cross-compile C and C++ code. And this is something that Rust doesn't do. Rust knows how to cross-compile Rust itself, which is awesome. But if you have a C dependency in Rust, it's on you to make sure that that dependency compiles on all the different platforms. And most importantly, cross-compilation is out of the question at that point, unless you figure it out yourself how to cross-compile the C part.
Okay, so let me paraphrase and offer a perspective, and you tell me what you think about this. So given that Rust and Zig are both trying to be better C, modern C, modern C++, their philosophies are somewhat different. Yeah. Rust is optimizing for safety, particularly memory safety, and Zig is optimizing for control and explicitness and predictability.
Yes, and in terms of how you integrate with I guess you can call them brownfield projects, like projects where you're not starting completely anew, but you need to coexist.
Legacy code.
Legacy code. With Zig, we are explicitly aiming for integrating with what's there in a more intimate way than Rust would, and also gaining benefits from having a mixed project. Because, and again, this is not knock on Rust, but with Rust, your guarantees come from Rust safe code. The more logic you can express as Rust safe code. So Rust code that doesn't have unsafe blocks. The more logic you can put in there, the more guarantees you can have. The more mileage you get out of the compiler, the borrow checker. But if you interact with code that is not in there, then Rust doesn't really give you much support. With Zig, this is completely different. We have a lot of tiny details in the language that are designed. Let me put it this way. And this is maybe a funny, maybe a little bit boastful claim, but I would be happy to substantiate it if necessary. It's easier to use C libraries from Zig than from C itself.
That's pretty cool. So you can add a Zig compilation unit to a C program. You're out there, you're listening to this podcast, you've got a big C++ program, and you're like, I don't want to touch any of that. You can drop Zig in, and it just works.
Yes. And let's say that you're using a C library from Zig. Here's a couple of things that you have at your disposal that are pretty neat. One, in C, you don't have a distinction between pointers to many items versus pointers to one item. It's not well defined in the language. I think there might be some new annotations that you can put, but they're not everywhere. In Zig, these things are explicitly written, like they are explicit things in the type system. If you have a pointer to many, for example, you cannot dereference as if it were a pointer to one item. If you have a null terminator, be it a null byte at the end of a string or something similar, but with different types, that is also part of the type system. You can create a string. You can create a pointer, which is, for example, a pointer to bytes, to many bytes with a null terminator. So now this is in the type system, and you cannot get it wrong. You cannot say, "Oh, I thought that this was supposed to be a null terminated string, but it turns out it's not." That cannot happen because it's encoded in the type system. We have defer. So cleaning up, resource allocation, it's not as fully automated as it is with Rai. It's still a bit more manual, but it's very nice to be able to allocate a resource and immediately defer free it or defer. So we have a variant of defer that only triggers when you are returning with an error. And so that the idea is, on success, the resource needs to be returned to the caller. On failure, you want to free everything. So you use defer in that case. And it is much better than having labels at the end of a function and doing go to them. There's a long list. These are just...
Yeah. It seems like Zig values explicitness and clarity, and it doesn't like things that are hidden.
No, it does not.
Yeah.
It's similar to C in that sense.
Yeah.
I would say that Zig is more of a modern C than it is a modern C++ in that sense.
Okay. It does also offer something very interesting that I want to understand more of. It's called Comtime.
Yeah.
And it doesn't have a preprocessor. It doesn't have macros, but it allows you to say, I want this code to run at the time of compilation rather than at runtime. And the more I read and learned about that, I'm like, why aren't we all doing that? You know what I mean? Like there's aspects of that in C Sharp in the build system, but this is kind of like built into the language itself. It's not built into the build system the way kind of C Sharp does it.
Yeah. Well, I don't know what the answer is, but why not other languages are doing it. What I can tell you is that for Comtime to work as naturally as it works in Zig, one compromise that we have to make is that Zig needs to do lazy evaluation. So one thing that tends to trip newcomers is that if you write a function, but you never call it, if the function has a syntax error, that gets caught because the file has to be parsed. But if you have a semantic error and the function never gets called, your function will not be analyzed and your semantic error will not be caught until you, let's say, wire that function in the first time. That surprises people, but and sometimes people mistakenly assume that it's done for performance reasons, which is not the case. The reason why we do this is that the benefit that you get from lazy evaluation is that, for example, this applies also, for example, to if statements that have a Comtime known argument. So if your if is solved at Comtime, we don't even analyze the losing branch. What you gain from this is that, for example, multi-platform code becomes weirdly natural because, for example, you can have a switch statement where you have each branch correspond to a different operating system. And in the Windows branch, you use Windows APIs. You use Windows definitions that don't even exist in the other OSs. And you don't have to do any special guarding around that because that branch will not even be analyzed when you're compiling for macOS, for example.
Okay, so let's just poke on that for a little bit.
Yeah.
So there's kind of like three ways to do that I want to call an API from multiple operating systems. I'm making an executable. I want it to run on Windows, Mac, and Linux. I can go and pound define my way through it. If def Windows do a thing, that's a preprocessor, and then we'll have whole chunks of code that will only compile on Windows. I can do it at runtime where I detect my operating system. And, if I detect it incorrectly, I might end up calling into an extern C that doesn't exist. How is Comtime in that context different from just saying if-def? Because you can have an entire chunk of code that only compiles if I'm on Windows.
Yeah. The difference, I guess, is that on one hand, the if-def doesn't get syntax analyzed, right? You don't have to have correct syntax in there. because it gets just chucked away. But that, I think that's not a particularly interesting difference. In the case of Comtime, I think there are other situations where where the sophistication that you get out of Comtime becomes more evident. So let me give you another example.
Yeah.
At Comtime, you can query a type for whether it has a given function or not, or a given field. So you can say, does the like std.os, the current std.os, does it have this function? And if it does, then I'm going to be able to call it. If it doesn't, then I'm going to be able to I'm going to call something else. So that is, for example, one way in which you can express your logic to support multi-platform targets, support different targets.
Okay. So ifdef is hiding code from the compiler and doing text substitution, but Comtime lets the compiler think about the code, reason about the code, and do all of that work. So you're not going to have paths that don't get run. They're not going to rot because the compiler sees all.
Well, it depends. In some cases, the compiler will not analyze semantically some branches, so it will catch syntax errors, but it will not catch semantic errors unless you leverage that branch. So it is common in Zig, for example, since we can do cross-compilation, it is common in Zig to have CI that just runs builds for all targets on one machine. Like, you don't need different machines. So on the same machine, you just do 3 builds for all the different targets. And it works.
Wow. So Zig is run as a software foundation. It's a non-profit.
Yeah, it's a 501c3.
Are there giant companies that are pushing Zig in one direction or the other?
No. So we are very small and independent. To be fair, we're not against big tech investment in Zig, but we don't give out board seats, to be clear. So
you don't get bought.
I mean, it doesn't. I guess that's one way of looking at it, but it doesn't have necessarily to be evil, but it does have at some point misaligned incentives, and we don't want to play with that. Let me put it this way: I don't think any of us thinks that we are particularly smart when it comes to this stuff, but because of that, we try to not play with fire. So no big tech companies in the board of directors. We try to diversify our income, so we get donations from some big entities, but also we are very careful about having also donations from the general public, and we try to keep it a balance. We for example, are deliberately avoiding to get in a situation where we have one gigantic donor that maybe doesn't have board seats, but once they pay the salary of all the people at the company, then saying no comes at a cost.
Yeah. And you actually have moved from GitHub, owned by big giant company that I work for, to Codeberg, which is a nonprofit Git hosting.
Yes.
Yeah. And do they do the builds as well, or where's the build servers?
The build servers are our own, and they were our own also. Like, we self-host the CI runners. We were also doing that on GitHub because some of our builds are very long, because we are testing basically a matrix of all kinds of cross-compilation. So like, we're doing builds not only for Windows, but we're doing builds for Windows, from Linux, from macOS, from FreeBSD, from NetBSD, from Haiku. So it's a lot. Plus tests, not just builds. Yeah, but the reason why we moved is not one of principle necessarily. The reason why we moved is because we were having trouble with GitHub Actions. GitHub Actions had started running weird and giving us trouble. Also, we were kind of annoyed at the safe sleep stuff. I don't know if you heard about it.
Yeah. There's a lot of drama about that right now.
Yeah, it's unfortunate because I still have email notifications on some of those issues, and I keep seeing people that watch YouTube videos and then go
and yell.
Yeah, makes no sense. But yeah, that was annoying. If I have to be honest, that was annoying. You log into the server, you don't know why your CI pipeline is falling behind, and then you see that there's a safe sleep that has been running for like 2 months straight.
Was that the reason that you left, or did you have other reasons to go to Codeberg?
I would say that those were the main reasons why we left. As for why Codeberg and not, say, for example, I don't know, GitLab or
Sure.
something like that, um, I think it's because I think our experience as of late has been that non-profit services that we've been using, maybe we've been lucky, but the non-profit services that we've been using has turned out so far to be the most reliable over time. Like other companies, they keep changing. They change their pricing models. They change the set of features that they want to have. They change the company direction, and it's annoying because we're not that many people at the ZSF, and we don't really like having to deal with this stuff. We just want to code, and it's annoying when you have nobody wants to log into the server and diagnose the runner. So I'll give you a different example of a nonprofit company that we've been relying on that we had a very positive experience with. It's called every.org. It's a website that allows you to accept donations, kind of like GitHub sponsors. We also had a good experience with GitHub sponsors, but every.org allows more payment methods that the GitHub sponsors doesn't allow. For example, somebody in the past has donated to us Apple shares, cryptocurrency, and so Every manages all this stuff transparently for us, and it's really nice. So they are nonprofit, and as long as we've been using them, it's been just smooth sailing, and we know, or rather, I guess we don't know for sure, but I think we can reasonably hope that they're not gonna pivot into, I don't know, becoming an AI company tomorrow, which would be very annoying.
Yeah, I like that though. Like, we just want to code, and like a company says something's going to be free forever, and then capitalism happens, and then it's not going to be free forever. Yeah. But for something like Zig, nonprofit makes sense, and Codeberg makes sense as well. I also want to mention, as we get towards the end of the conversation here, if folks are thinking about like what's a great example of a big important Zig project, I think it's worth noting Bun, which is a high performance JavaScript runtime, right? So it's kind of like Node plus npm plus esbuild all in one thing. It's written largely, if not completely, in Zig. Is that right?
Yeah, I would say largely because they depend on JSC. Which is I think is it from Apple? Well, it's the other V8. It's the one that is not V8. It's a JavaScript engine. Right. Which is a big dependency, but everything else is Zig. Yes.
Yeah. It was. Did they? Did you know this was happening, or do Zig projects just pop up and you're like, oh wow, that happened. We didn't even know.
Sorry, you mean Bun using Zig? Or
Bun using Zig. Do they call you first, or does it just happen?
No. But Bun started from just one guy. So one day in Discord, one guy shows up and is asking how to do C interoperability because he wants to make his own JavaScript engine, which happens from time to time, and you don't really think
random internet person wants to do a thing, and you never know it's going to become Bun.
Yeah, and so he kept it, and at some point he had a Discord server where there was a channel where you would type "I want Bun." And if you type that, you would get an invite to the private GitHub repository. And then at some point he published it, and well, the rest is history.
Wow. That must be a vote of confidence towards Zig, not only as a great programming language, but as a really valid C replacement. Because classically, I think someone would have written something like that in C. It would have made sense. And the fact that they picked Zig and they've had no issues, and Bun, of course, is now very well thought of, is pretty awesome. And congratulations to you and the team.
Thank you. Although I would say this, maybe this says that it's not too bad to get into systems programming through Zig. I personally do believe that. But ultimately, in this case, it's Jared. Jared, the guy in question. Well, I mean, he's the CEO of Bun, or was, I guess, because now they've been bought by Anthropic. That's on him. He was able to pull this stuff on its own.
That's so cool that a random person shows up in Discord and has questions, and then like fast forward a couple of years later, and then it's like, oh wow, that became a thing the whole internet uses, and now they got bought by Anthropic. Like, you too can make an awesome thing in Zig and get bought tomorrow.
I guess. There's another interesting project called Tiger Beetle. That one is a financial database written in Zig. They take it, in my opinion, also like even to the next level, even more than one. They do this thing where the database. So first of all, it's a domain-specific database. It's not SQL. It's not relational. It's not document. It's financial transactions. I forget the name for it, but you know where you have an account. It's balance. So you have.
It's a ledger.
Yeah, it's a ledger. Thank you. Stuff coming in, stuff coming out.
Right.
It has to balance out.
Yeah, it's a big distributed fault-tolerant financial ledger.
Yes, and but not as in blockchain, as in
right, but not blockchain.
Normal database. And they do this thing where they start the server, they allocate memory, and that's it. They allocate memory at the beginning, and then they never allocate any memory anymore. It's like hard mode, old school C programming.
Wow. And in doing that, this is an example where a financial ledger is not a place where you want to do a GC language. You need no pauses, no hidden allocations. Yeah. You want to be very explicit. You need to have a deterministic layout on disk, tight control of your caches. I used to work in finance, and Zig making all these things kind of like enforceable and explicit makes it a great example. And now you've even got folks like OpenSUSE trying to go and do an SSH implementation in Zig. So there's lots of really fun and interesting stuff
also
happening in the space.
I mean, it's not maybe as serious as finance, but developers really care about their terminals. Yeah. And I don't know, that Ghosty by Michio Hashimoto is also written in Zig. And,
wow.
It's not on Windows yet, but he plans also to add support for Windows.
Yeah.
And a lot of people like it.
Well, this is great. Well, thank you so much. Zig is having a moment. Folks can check it out at ziglang.org. You can explore the code, download it, and get playing immediately. And certainly, if you or your company wants to, you can check out the Zig Software Foundation. They are a nonprofit, and they will accept donations. And certainly, they'll appreciate you showing up in the Discord and announcing that you're building something in Zig.
Yeah, even if it doesn't get bought by Anthropic.
Even if it does. We love you anyway. Thank you so much, Loris Cro, for chatting with me today.
It's been a pleasure. Thank you.
This has been another episode of Hansel Minutes, and we'll see you again next week.